I really like this problem. This is a good one. We're given a function that has a quotient in it, 9x over 4x plus 1, and this entire quotient is raised to the 6th power, which means it's really this fraction times itself 6 times, and we're asked to find the derivative of that function. Now, we need a couple of rules for this, right? First of all, we're going to need the chain rule, right? Which says, hey, give me the derivative of the inner function times the derivative of the outer function. That is, covering up your stuff here, raised to the 6th power. So whatever stuff is raised to the 6th power, give me the derivative of the outer part. All right, I'll get to that in a moment. We're also going to need the quotient rule. Right, we're going to need the quotient rule. And in the quotient rule, it says, real quickly here as a recap, it says, hey, give me the derivative of the numerator, which we'll call f, right? And multiply that by the denominator, which we'll call g, 4x plus 1, and subtract from that the numerator, which we'll call f, times the derivative of the denominator all over the denominator squared. So there's the quotient rule. Okay, so armed with these things here, let's go find the derivative, right, of y. All right, let's go find the derivative of y. Scoot this down a little bit here. Y prime. Okay, so first off, if I was to cover up, right, here, I've got, I guess I'll just use, maybe I'll use this ruler for a second here, right? If I was just to cover up my quantity inside that parentheses there and just say, look, I've got some stuff raised to the 6th power, I hope you see it's that simply the derivative of stuff raised to the 6th power, well, it is 6, right, of that same stuff raised to the 5th power. But what was that stuff that's inside there? Oh, that was 9x over 4x plus 1. Right? So I'm using the chain rule here. The chain rule says give me the derivative of the outer, right? Chain rule says give me the derivative of the outer stuff, which I just found, times the derivative of the inner stuff. Okay? Now the inner stuff is a little bit more involved because the inner stuff says, okay, now give me the derivative of this quotient here, 9x over 4x plus 1. Well, that's where the quotient rule comes into play. Okay? So quotient rule says give me the derivative of the numerator, which we'll call 9x, which is simply just 9, right, times g, so I'll put in parentheses here, 4x plus 1, okay, minus f, which is the numerator, just 9x, times the derivative of g, which is this denominator stuff, which is simply just a 4, right, because the derivative of 1 is 0 and it goes away, so the derivative of 4x is just a 4. Right, all over g squared, right, all over my denominator. I'll write it as 4x plus 1 quantity squared. I'm not going to actually FOIL that out. I'll just leave it just like that. Okay, so let's clean this big parentheses up a little bit more. I'm going to take this 9 and distribute it to these two terms after it. Let's see, what do I have here? I've got 6. I've got 9x over 4x plus 1 quantity to the 5th power. Okay, now let me go ahead and distribute this 9 times both of these terms over here. That gives me a 36x plus 9, right? And then if I multiply these two together, I simply just have a minus 36x. Hey, do you see anything in the numerator that's going to cancel itself out? Yeah, sure enough, look, I've got 36x here, I've got negative 36x here. These guys are out here, they cancel each other out, okay? So I hope you see that my first derivative, if I can squeeze this in here, is 6 times 9x over 4x plus 1 quantity to the 5th power times simply just a 9 up top in the numerator over quantity of 4x plus 1 squared. Okay? Alright, well, let's see. If I was to clean that up a little bit more, and I'm going to use my calculator here to figure out, because you've got some big numbers about to come up here, do you see that this right here simply means 9x to the 5th power. That is 9x times 9x times 9x times 9x. I got a whole bunch of them, right? So I really have let me do it this way. I really hope you see that this exponent of 5 here makes this 9 to the 5th and x to the 5th. It really affects both of those there, okay? It also affects this 4x plus 1 on the bottom. It really makes it so that there are 5 of those as well. It's like taking this original fraction here of 9x over 4x plus 1 and multiplying it by itself 5 times. So there would be 5 9s and 5 x's on top, as well as there'd be 5 4x plus 1s on the bottom. All right, so using exponents is a way shorter way of working this out here, okay? All right, so here's what I've got. I've got I've got 9 to the 5th, x to the 5th. I've got a 4x plus 1 quantity to the 5th. Right? I had a 6 out front, and I also have, I'm multiplying by another 9 and 2 more of these 4x plus 1s going on. Right? So I hope you see, if I'm just looking at the denominator for now, do you see that I have a total of 7 of these 4x plus 1s, right? I've got 5 of them here, I've got 2 of them in there. Since the bases are the same, I'm just going to keep the same base of 4x plus 1 and say, hey, I've got a total of 7 of them all together, okay? I also have an x to the 5th up top, right? That's just coming from right here, an x to the 5th. But as far as all of the numbers are concerned, as far as all the coefficients are concerned, here's what I've got, okay? I'm going to pull up my calculator now. Use this guy, I'm going to need it. I have a 9 times 9 times 5 of them here, really. So I've got a total of 6 9s altogether, right? I've got 5 of them here, 1 of them here. I really have 9 raised to the 6th power. And that's some huge number, right? 531,441. But don't forget that that constant is also being multiplied by 6. So I got to multiply that by 6 times 6. And I get this really big answer here of 3,188,646. All right, I'll put that right here. 3,188,646. And there is my final answer. Let's get rid of that calculator. All right, here is my final answer to this first derivative. Isn't that pretty big? All right, so it's 3,188,646 x to the 5th all over 7 of these 4x plus 1s. Hope that helps.